What's up guys, welcome back to Tank Control Games. In this episode, we're going to be creating real-time surface deformation in Unreal Engine 5, so as the player moves, they're going to be creating depth in the ground, and this is going to be perfect for things like snow or mud. We're going to be starting from the default third-person template in Unreal Engine 5.7.2, using render targets and runtime virtual textures along with virtual Heightfield meshes to stamp deformation under the character in real time. Also, shout out to Limits Free Games, whose project on their channel helped me understand the core concepts behind this implementation. We're going to be using a lot of what they set up in their project, but we're going to be restructuring and simplifying it for our needs. So by the end, you're going to have a reusable surface deformation system ready to build into your own project. So if that sounds interesting to you, make sure you like and subscribe and we'll get started. Okay, so when your project first loads, you want to go to Edit, Plugins, and then search for Virtual Heightfield Mesh. And I already have it enabled in my project, but once you click this, it'll have you restart the engine. So with that enabled, the first thing you want to do is go to the Quickly Add to Project button and search for Virtual Heightfield Mesh. And then let's just modify the scale of this mesh. So let's set it to something like 1000 in X and 1000 in Y and then 100 in Z. And then you can just drag this off to the side here. Then we also want a runtime virtual texture volume, so we'll search for that. And then for this volume, we want it to match our Heightfield mesh. So it's going to be 1000 by 1000 and then 100 in Z. And then you want the locations to match too. So we're just going to take our Heightfield mesh and we're just going to copy the location. And we'll just paste that into our runtime virtual texture volume. So now they're both overlapping each other and in the same spot. And we'll be able to move this around later and mess with it. Next, we're going to create a runtime virtual texture. So let's go to our content drawer. Right click and then search for runtime virtual texture. And we're just going to call this RVT underscore VHM height. And then double click that open. And then we can leave everything default here except for the virtual texture content, which we'll set to world height. Then we can close that and we're going to also create a material. So let's right click and do material and name it M underscore VHM landscape. And then we also want to make a render target, so let's right click and search for render target, and then call this RT underscore surface mask. And then let's double click open our render target, and we're going to change a few settings in here. So for size, let's do something like 4096 by 4096, which is 4K in a 1x1, and this is maybe overkill for this. We probably can actually lower this later if we want better performance. Then we're also going to set render target format to be RTF8. And then just click yes with the warning. And then we can close our render target. Then we're going to create one more material. So we'll do material and call this M underscore surface mask brush. And this is what we're going to use to paint onto the render target. Okay, then we also want to make a blueprint actor and we're going to call this EP surface deformer. And this actor is going to be placed into the world. And actually, let's just drag that out into the world now so we don't forget later. And this is initially going to be how we run all of our painting logic, but in the future, we're probably going to move this to an actor component. Cool, so you can save all of those. So highlight them all, do save. And then what we can do is select our runtime virtual texture volume. And then in the settings where it says runtime virtual texture, we are going to set this to be our created RVT VHM height. Then we want to select our virtual Heightfield mesh. And then we're going to go under Heightfield build, so drop that down. And then for Heightfield build under min-max texture, it's not going to have anything there because we actually have to create this. So what we can do is under where it says min-max build levels, we can add 5. And it won't let you build just yet. So first we actually have to add our Heightfield and virtual texture. So under virtual texture, we're going to set this to be our runtime virtual texture volume. And then under material for rendering, we're going to set this to be our landscape material that we created. And then we're also going to want to uncheck where it says actor hidden in editor, because we do want to see our virtual Heightfield mesh. And then if we go up now, we should see that build is available. So if we just click that, it's going to have us create this RVT VHM height min max. And we can just save that in our content folder for now. Okay, so now let's click open our new min max file that we created. And we should see number CPU levels 5. This all looks good. And then let's go back to our settings and just set min-max build levels back to 0 and just click build. Okay, so if we drag up our virtual Heightfield mesh and our runtime virtual texture volume, you'll see right now the virtual Heightfield mesh, since we added that texture, just has a black surface, and that's fine for now. So what we can do is go to our M surface mask brush. We'll just set this up first because this will be pretty simple. So in the material, what we're going to want to do is first get a texture coordinate node. So drag off of texture coordinate and get a subtract node. And we're going to subtract this from our draw location, which we're going to get in our blueprint. So this is going to be a parameter. So first press 3 on the keyboard and click, and then right click on our vector and convert to parameter. And we're just going to call this draw location. And then we just want the X and the Y from this. So we're going to do component mask and just do RG. So you can just leave that as default and then hook that up to the subtract. And then let's comment this section. And we'll just call this convert draw location to UV space relative to current pixel. And then we'll pull this to the side. Then the next thing that we can do is we're going to drag off of subtract and we're going to get vector length. And then off of our vector length, and actually we want this to go, instead of vector 3, we want it to go to vector 2, since we're just using the X and the Y. And then we're going to drag off of that and do subtract. And we'll do the subtract into the B actually. And then we're just going to do 1 minus this. So we're going to grab a constant and just do a constant 1 and do subtract like that. And then we can comment this section and we'll call it compute radial distance from brush center and invert for circular fall off. And we'll pull that over to the side, make a little more space for ourselves. Then what we can do off the subtract is do another subtract. And then we're going to scale the brush size relative to the world size. So what we can do is make a couple parameters. So let's add 2 more constants, but then we're going to convert them to parameters. And we'll call this first one brush size. And then we'll call the second one world size in meters. So just world size meters is fine. And then we're going to divide those. And then as defaults for now, let's just do 1 for the brush size and 120 for the world size. And then we're going to do a 1 minus. And then we're going to hook the 1 minus up to the B of the subtract. And then we're also going to clamp that between 0 and 1. So search for clamp. And we'll just call this scale brush size based on object size relative to world. And then for the top nodes, we'll just call that apply brush radius and clamp. And then lastly, what we're going to do, we're going to normalize and scale the final brush. So we can do drag off of our clamp and get a divide, and then hook up our divide node. So not the 1 minus. So make sure you just get it off the divide. And then we're going to divide from there and pull off the divide and get another clamp. And then lastly, we'll get a multiply. And then you'll multiply this by your brush strength. So we want another constant, convert it to a parameter and just call it brush strength. And just hook it up like that. And then we're going to plug all of this into the emissive. And then we want to change our material settings. So instead of blend mode being opaque, we're going to make this additive. And then we're also going to make it unlit instead of default lit. So it's just basically going to have the emissive. And then we'll just add a comment here and just say normalize and scale final brush mask using brush strength. Okay, so that should be the full circular brush. And I think this is mostly the same brush logic from limits free games, but this works pretty well for our test. And we are actually probably going to make a unique brush when we do footprints, but this should work for now. So I think we have everything. Let me just check the defaults. We probably want to do brush strength, default that to 1. And then for our default draw location, let's just make that in the center. So we're just going to do 0.5 for R and 0.5 for G. And then let's just save that. Okay, so let's build our other material. So if we go back to our content drawer and we have our landscape, let's double click that open. Okay, so select your material, and then under the settings, we're going to change a few things here. So we're going to use material attributes. And then if we scroll all the way down to the bottom, you should see pixel depth offset mode. And then we're just going to set legacy there. And then we also want to use this with Virtual Heightfield Mesh, so make sure that that's checked. Okay, so the next step is we're going to right click and get a set material attributes node and just hook that up to the material attributes, and then a make material attributes node. And then to start for our base color, we're just going to use just a white color. And this can actually be a texture later on, but for now, we're just gonna set this to be white and just plug that into base color. And maybe we'll make it like slightly off white and click apply. And then for roughness, we're just gonna want that to be 1. So we'll just make a constant, plug it into roughness. And then we're gonna need to make some parameters. So the first one we're gonna get is called normal map offset per meter. And we'll convert that to a parameter and just set that to 0.2 and then drag off of that and do divide. And then let's make another parameter and we'll call it world size meters, just like in our brush. And then set that to default to 120 and hook that up to the divide. So in the original project that we're basing this on, they were setting the world size kind of hard coded to 120, but we're gonna set it so that no matter what our volume size is, it'll change automatically, but we're gonna do that a little bit later. So first we'll do this and drag off of our divide and then get multiply. And then we need another parameter. So let's create it and call it normal map direction. And we'll make that default to -1. So let's comment these sections. So we'll call the first one normalize height to normal strength by world size. Okay, so then let's drag all this off to the side and then let's get a object texture parameter or texture object parameter, and we're going to call it RT surface mask. And then this is just going to point to our render target that we created earlier, so RT surface mask. So then from our mask, let's drag and get a normal from height map node, and this goes into height map just like that. And then what we want is for normal map intensities, let's make a constant, just make that 1. And then for height map UV offsets, that's going to be our multiply. And then for our coordinates, we're going to get a landscape coordinate node. So I believe it's just called landscape layer chords, and then hook that up into the coordinates. And then what we can do from here is drag this again, and let's just comment this section and we'll just call this feed surface mask into height to normal conversion. Then drag off the result and get a blend angle corrected normals. And then for the additional normal, we'll just get a texture sample. And then just for now, let's just make this sample use base normal. What is this called? T base tile normal, which just kind of has this random texture to it. We'll replace this later with something that feels like snow and mud when we get to that point, but for now, just plug the result into normal. And then, yeah, you'll see it'll give this kind of texture to our snow. And it's not gonna look perfect, but like I said, we can replace this later. Okay, so next we're gonna calculate the world position offset. So what we wanna do is get our landscape coordinates again. So we'll just pull this down here. And then let's get another texture sample and then hook this up to the UVs. And then for the actual texture, we're gonna get our RT surface mask again. So we can just copy this down and hook that up like that. And we can call this in a comment sample surface mask from render target using landscape UVs. And then we can drag off the RGB, or actually, sorry, we can drag off just the R and do multiply. And then we're gonna multiply this by a vector. So let's make a new vector, and it's just gonna be 0, 0, and 1 for the constant. So just like that, and then hook that up to the multiply. And we'll comment that and call it select mask channel used for height deformation. And then drag off the multiply, and let's get a power. And then the power is just going to be used to adjust mask contrast to sharpen the deformation. And this is probably a little too detailed with our comments, but just so that everybody will understand what we're doing. And then we can drag off of that and get a multiply. And then we want to create a parameter for the depth of the material. So let's create not a vector, just another parameter, and we're going to call this depth. And then for default, let's just set it at like 10 for now. And we actually want to multiply this by -1. So we'll do multiply -1 and hook that up to the B. And then we can call this scale deformation, depth using surface depth parameter. And then we can just hook that directly up to our world space offset and then click apply. So that should be everything we need in our parameter for now. Let me just check our default values look good. So we can just save that material and then we can move on to the next step. So let's work on our surface deformer now. So open your BP surface deformer blueprint And then we're going to need some default variables in here. So let's start with the references we need. So to make this work with any volume size in the world, we want to reference directly our Runtime Virtual Texture volume and also our Virtual Heightfield Mesh. So let's add 2 variables for those. So we'll search for Runtime Virtual Texture, Runtime Virtual Texture Volume object reference. We'll just name that RVT volume ref. And then let's also make one for the Virtual Heightfield Mesh, and we'll rename that to VHM ref. And then for both of these, because these are things we want to select from our map, let's just check the I button to make them instance editable. And then you can go back in your world, and then you can find your surface deformer, and then now you'll have under default the option to actually set these. So for your volume, just make sure you use your volume, and then for your Heightfield Mesh, select the Heightfield Mesh, and that should be good. So let's go back to our blueprint, and then on begin play, let's do something initially right when the game starts. We want to clear our render target, because you'll notice basically a render target is something you can actually paint to. Think of it kind of like a canvas. So you're directly painting on this, but you need to clear it when you start the map, otherwise it'll retain kind of the deformation you had previously. So what we can do is right click and do clear render target 2D, and then we want to find our RT surface mask, and then the clear color is black, because you'll see it kind of paints red when you start drawing on this, and then you just clear it by setting it back to black, so that should be good. Then we want to get a reference to our third person character, so let's get player character, then do cast to third person character, just like that, and then let's store that reference, and we'll just call this third person character ref. Cool, so then let's add a sequence after all of this. So the first thing we can do is create a new function, and we'll just call this compute RVT volume bounds. And then in this function, let's also make a sequence node. And the first thing we'll do is get our volume ref, and then let's do get actor bounds. And you can keep only colliding components and include from child actors unchecked. And then what we can do is drag off of this and get a subtract node and subtract the origin and the box extent. And that's going to give you your stamp min. So let's promote this to a variable and just call it stamp min. And then what we also want to do is get stamp size. So for the size, we actually just want to take the box extent and multiply it by 2. And then drag off there and promote that to a variable and just call it stamp size. And just hook up our stamp min like that. And then the last thing we want to calculate in here is going to be the RVT world size in meters for the brush scaling. So the way we can do that is if we get the box extent again, and then we break the vector, and we can multiply x and y by 2, and then divide by 100. And then the results of both of those divide nodes, let's do a max float node. And then that's going to be your world size. So we'll just promote that to a variable and call it world size. Okay, so that looks pretty good. Let's go back out of this function, and in our sequence node in the event graph on begin play, we'll just drag out our function. Next, we want to create our mids for our virtual height mesh material and for our brush material. So what we can do is we can actually get our virtual Heightfield Mesh reference and then drag off, and let's get the component. So search virtual Heightfield Mesh component, and then this will let us get the actual texture that's applied to it. So what we can do is drag off of the component, search for create dynamic material instance. And then for the source material, let's find our landscape material. So VHM _ landscape, and then drag off the return value and promote to variable. And we're going to call this landscape material mid. And just one thing to note, in this project, we're not actually going to be applying our deformation onto the landscape. So this is kind of a hacky setup just to show deformation on the Heightfield mesh. But later on, we're actually going to apply it to the landscape, and I'll show you how to do that as well. So let's drag off of here and just hook this up to our sequence. And then one last thing that we'll do is at the end on this mid, let's drag off and do set scalar parameter value. And then this is going to be what we called our world size in meters, which I think is just world size in meters. Let's double check. Yeah, world size meters. So you can just copy that name directly. Very important that the names match, and just paste that under parameter name. And then for the value, let's promote this to a variable. Or sorry, we actually already have our world size variable, so we'll just drag that and hook it up. Cool, so now we can do the world size for our brush. So it's going to be pretty much the same process. We'll just copy this node down, and then we'll just find our brush our brush material. So I think we just called it surface mask brush. And then what we can do is just add another sequence, hook that up directly, and then promote this to a variable, and we'll just call that surface mask brush mid. And then we're going to set a few scalar parameters off of here. So let's drag off set scalar parameter like we did before. Set scalar parameter value. And then for the first one, let's make this brush size is what I think we called the variable. And then this will have a value here. So let's just promote this to a variable that we can set on this actor. Oh, and then I realized we used the wrong create dynamic material instance node. So let's search again, create dynamic material instance. And yeah, we just want this one. So hook that up like that and do compile. And then again, we have to set our M surface mask brush. Okay, so we're good there. And then the next thing we want to set is our brush strength. So let's copy this over and just call this brush strength. And then we'll promote that to a variable as well. So for brush strength, let's make the defaults something like 0.1 for now. And then for size, we'll do 0.7. And then we just want to make sure our mid is also hooked up to this. And we can add a reroute node and just kind of clean this up slightly. And then the last thing we want to set is the world size in meters again. I think we called it exactly the same as we did in the other material, so we can just hook it up like that, and that should work. Okay, and then initially we're going to set this up to kind of just print off of begin play, so it'll just start printing right away. We'll do what they did in the example project they released, so we're going to do delay, and we'll just make that 1 second, and then add another sequence node, and then we're going to do set timer by function name, and then for time let's do 0.016, and then also check looping, and then for function name we haven't made it yet, but let's drag off of our return value to promote to variable and just call this stamp timer, and then compile and save. So let's make our functions now, the function that's actually going to stamp. So actually the first one we'll do pretty much what they did in the demo as well. We're going to make a new function, and we're going to call it limit surface mask update, and then we only want them for this actor to stamp while the player's moving, so we're going to get a branch, and then we're going to make a variable. Let's make a vector, and we'll just call this last actor location, and then we'll get an equal node, and then let's make this error tolerance 0001, and then for the B we're going to check it against the current actor location, so we're going to get the player character, and then we're going to get actor location and just hook it up like that, and then plug that into our branch. So this will be our condition, and then when this is false, we're just going to set last actor location to be the current actor location, and then also draw onto our surface mask. So let's make another function and just call this draw surface mask, and then just drag that function out, and we'll hook that up right at the end here. So this will only ever fire when you're not when you are moving. And again, this is not probably how we're going to set it up when we do the footprints, but this is just good for a quick test so that we can actually see our deformation working. So let's go to the draw surface mask, and then we'll set this up really quick. So let's get a reference to our character. The first thing we're going to check, we're going to get character movement, and then we're going to check if the character is falling. Okay, then make a branch, and we'll just hook that up to the branch for the condition. And then if we're not falling, then we're going to do a line trace by channel. And then for the line trace, we're just going to do something really simple. So we'll just get the third person character and then get mesh. And then we'll just do get socket location, and we'll just get the root. And the root will be the start, and then the end will be the root minus some value in Z. So we'll just say like 200. Just kind of a quick and dirty way to set this up. And then for now, let's just draw a debug for duration so we can see what's happening. Then let's drag off of our out hit and do break hit result. And then from location, let's do subtract. We're going to subtract the stamp size. And then we're going to divide that. Oh, sorry, actually, I'm wrong. We're actually going to subtract the stamp min, and then we're going to divide by the stamp size. And then we can break that vector. And then we can do a clamp on the X and Y. So we want to clamp it between 0 and 1. And then we can do make vector again. And then we can comment this section, and let's just call this convert world hit position into clamped 0 to 1 UV space for our RVT mask. And then we want to update the brush position. So what we can do is get our brush mid that we created earlier. So our surface brush mid, and then we can drag off of that and do set vector parameter, set vector parameter value. And then the value is going to be our draw location that we created. And then we can just take the vector and then convert it from vector to linear color structure like that. And then the last thing we need to do to make sure this actually draws onto our render target is get that parameter. So I believe it's just draw material to render target. And then the render target is going to be our surface mask that we created. And then the material is going to be our mid. So let's just reorganize this slightly and then just drag and connect all of our nodes. Okay, so now the last thing we need to do is go back to begin play. And then under our set timer by function name, let's just get our function and just paste it in. And then you want the limit surface mask update since that adds our draw mask after. And then let's do compile and then click play. So if we walk through our volume, you'll see it is now deforming the mesh, and it's a little subtle. So let's actually bump up the brush strength. So from 0.1, let's put like 0.5, then do compile and play again. Yep, there we go. So now it's using our brush size that we created, and then it's only painting while the character's moving. So that's working pretty good. So something else that we can test here is if we actually go to our landscape material, and then we go to our depth parameter, we can bump that up to something much higher. So like 100, and click play. And then you could even see when I played it there, it was updating what we had previously painted. But if we walk over now it'll paint much deeper. Okay, so the last thing I can demo for you is if we take our volume and our height mesh and we just scale this up. So we'll make this something much bigger. And then we click play, and then we run through it again. You'll see it maintains that brush size, which is really nice, so you don't have to keep resizing the brush every time you scale up your mesh. So that's going to do it for this video. In the next one, we're going to take these concepts and apply them to footsteps in the snow or mud or whatever material you want to leave persistent footsteps in. And we're going to use the setup that we did in our surface detection series, because that has a lot of the code we're going to need for that. So did you enjoy the video? If you did, please leave a like and subscribe. It really helps my channel grow. If you have any questions, message me on Discord. And if you want to just show off your work or you use this to make something cool, definitely share it in the Discord channel under the Showcase channel. So thank you guys so much for watching, and I'll see you in the next one.